Hello everyone, welcome to edupediaworld.com and thanks for watching Edupedia World videos. This is Vikas Patil. This is the 11th chapter of grade 9, Fluvial Geomorphology. In this chapter, we are going to explore in detail about the way running water carves landforms on the surface of the earth. As discussed in the previous chapter, erosion is the process of disintegration, transportation, and deposition of rock particles. Erosion is carried out by dynamic agents like river, glaciers, and winds. Another important point about erosion is that the broken rock fragments are instantly removed by the above-mentioned agents, exposing a fresh surface of the rock every time a rock is eroded. Together, weathering and erosion are known as denudation. Fluvial geomorphology is the study of landforms created by running water. Of all the landforms created by external processes, these are the most prominent and prevalent. If one sits back to think and assess, rivers have been responsible for the creation of new lands and obliteration or alteration of lands that once existed. In this chapter, we are going to explore how running water causes erosion and also the landforms created due to erosion and deposition by the running water. This chapter has been divided into 4 topics. Introduction to the river. Upper course of river, middle course of river, and finally the lower course of river. This is the first session of the chapter. In this session, we are going to learn details about the river. In this session, we are going to try and achieve the following objectives. Define erosion. List the various agents of erosion. Analyze the different types of load carried by the river. Compare the different processes through which a river erodes. List the factors that affect the work of rivers. Before we begin our exploration about rivers, let us look at some of the common misconceptions that exist regarding the same. First, river has only one starting point. Second, river water does not contain salt. It is fresh. Third, load carried by the river is similar in all its courses. And last, rivers only get water from rain. Well, all these are myths. Let us explore the facts. Rivers and streams complete the hydrologic cycle by returning precipitation that falls on Earth to the oceans. Ultimately, gravity is the driving force. As water moves from mountainous region to sea level, some of this water moves over the surface and some moves through the ground as groundwater. As this water flows, it does the work of both erosion and deposition. First things first, let us get clear with certain important terms that we are going to come across during this chapter. Source. Source is from where the river begins. A river may obtain its water from three main sources: rain, glaciers, or groundwater. A river may have more than one source of water. Catchment area, also known as a watershed. The area, usually in the mountains, consisting of all streams which join together to make the main river. Two adjacent catchment areas may be divided by what we call as a water divide. Tributary. Tributary is a small stream joining the main river. It could be a small river joining the main river. Distributary. It's a stream branching out of the main river. So distributaries distribute the water of the main river. Confluence. Confluence is the place where a river or stream meets another river or stream. Discharge. Discharge is the water content of a river at any point of time. It is measured in cubic meters per second or cusecs. Channel. Channel is the path of the river during times of low discharge. River valley. River valley is the path of river during times of high discharge. Load. Load is the sediment content of a river. This may be of three types: that's traction, suspension, and solution. Gradient. Gradient is the slope of the river bed. Gradient decides the velocity of river. Mouth. Mouth is the place where the river meets any stagnant water body, like sea, lake, or ocean. Running water can move mountains and turn them into flat land. It is so powerful. Of course, it doesn't work at jet speed, but gradually does its work through hundreds of thousands of years. The story of river begins as a raindrop. Many small raindrops combine to form rills, which further combine to form channels. When channels combine, they are called ravines, which further combine to give rise to streams of first order. Here, the river begins to gain size. Streams further combine to form the main river. Just look at these terms. All these are connected to river and work of river. Waterfall, load, oxbow lake, floodplain, meander, tributaries, distributaries, delta, gorge, canyon, rapids, alluvial fan, alluvium, estuary, erosion, discharge, levee, they are all connected to the work of river. River is the most dynamic and effective agent of erosion. The first question that arises is that when the river moves, what material does it carry and how? Well, as mentioned earlier, all the material or sediment carried by river is termed as load. Some of these materials are carried as solution, which are dissolved in the water. Many minerals are ionic compounds that dissolve easily in water. So water moves these elements to the sea as part of the dissolved load that the streams carry. As groundwater leaches through layers of soil and rock, minerals dissolve and are carried away. Groundwater contributes most of the dissolved components that streams carry. Once an element is completely dissolved, it will likely be carried to the ocean, regardless of the velocity of the stream. In some circumstances, the stream water could become saturated with dissolved minerals, in which case elements of those minerals might precipitate out of the water before they reach the ocean. This solution load is the reason for the salinity of the ocean. Another way that river and streams move weathered material is as the suspended load. These are pieces of rock that are carried as solids as the river flows. Unlike dissolved load, the size of the particle that can be carried as suspended load is determined by the velocity of the stream. As a stream flows faster, it can carry larger and larger particles. The larger the size particles that can be carried by a stream, the greater the stream's competence. If a stream has a steep slope or gradient, it will have a faster velocity, which means it will be able to carry larger minerals in suspension. At flood stage, rivers flow much faster and do more erosion because the added water increases the stream's velocity. Sand, silt, and clay-sized particles generally make up the suspended load for a stream. As a stream slows down, either because the stream's slope decreases or because the stream overflows its bank and broadens its channel, the stream will deposit the larger particles it has been carrying first. The last way that rivers and streams move weathered particles is as bed load, which can be traction load as well as saltation load. It means that although the water in the stream is capable of bumping and pushing these particles along, it is not able to pick them up and carry them continuously. Bed load is named for the fact that these particles get nudged and rolled along the stream bed as the water flows. Occasionally, a larger size particle will get knocked into the main part of the stream flow, but then it settles back down stream bed because it is too heavy to remain suspended in the water. This is called saltation. Streams with high velocities and steep gradients do a great deal of downcutting into the riverbed. As you can see, saltation load, traction load, and suspended load. The next question that might arise here is, how does the river erode? River erosion is the gradual removal of rock material from the river banks and bed. The simplest way of eroding rocks is hydraulic plucking. It is the removal and dragging of rocks from the bed and banks of the river by the sheer force of the running water. Besides hydraulic plucking, river also carries a lot of ammunition with it, which results in greater erosion. It increases the erosive power of streams. Well, this ammunition is nothing but the rock pieces carried by the river. The river water picks up weathered rock pieces and use them as ammunition and cause greater erosion. This erosion can happen in multiple ways. First, abrasion. Abrasion is caused when the rock pieces are rubbed against the rocky river bed and river banks. Next is attrition. Attrition is caused when the rock fragments are pounded upon other rocks with force. Next is corrosion. Corrosion is the rubbing up of the rock pieces against each other. This results in these rock pieces getting rounded and smooth and smaller. And last is the solution, which we have already discussed. The solvent action of water, which dissolves soluble materials and carry them away in solution. A number of factors affect the way water erodes. First is the amount of water in the river. More water will result in more erosion, and less water will result in less erosion. Second is the speed of the river. Well, this is decided by the gradient of the riverbed. More speed results in more erosion. Slope of the riverbed will determine the speed of the river and subsequently erosion caused by river. Load carried by river, as mentioned earlier, is the ammunition of the river. More load will result in more erosion. Nature of the rocks in the valley will also affect the rate of erosion by water. Harder rocks tend to resist more than the softer ones. Therefore, softer rocks get eroded faster than the hard rocks. This was all for this session. In the next session, we will try and understand what and how river works in its upper course. Don't forget to watch. Thank you.